We'll finish off these examples of u substitution by taking a look at ones again where you have to do a little bit, you have to change the way the integral looks before you do a substitution. So number 10 is one version of a kind of a classic, what are called trig integrals. And I mean, there are whole chapters in calc textbooks about trig integrals. And I think if you go into engineering, you probably have to know a lot of them, or at least when you do your undergrad courses, you'll have to know a lot of them. But in any case, cosine of x cubed seems like a kind of a conversation stopper. There's nothing really to do. If you let u be cosine, its derivative is sine, but there's no sine in this problem. And so it just doesn't seem like there's anywhere to go. But this is where you'll want to try to make use of all the trig identities you learned in your pre-calculus course. Cosine of x cubed, there's no easy to remember identity for that. But you could write it as cosine squared x times cosine of x. Now why would I want to do that? Well, because cosine of x squared has a nice identity, right? Recall that sine squared plus cosine squared equals 1. So that means I can rewrite cosine squared as 1 minus, I want to write it as 1 minus sine squared. This now just opened up this problem and allows me to make a substitution. So I'm going to let my u be sine of x. See what happens there. If you let that, if the u be sine of x, then du would be cosine of x dx. And you can sort of see how nicely that's going to work out for us. So this becomes 1 minus u squared, and cosine x dx is just du. In this integral, we can totally solve, because the antiderivative of 1 is the antiderivative of 1 is u. The antiderivative of u squared is 1/3 u cubed plus c. And so this is equal to sine of x minus 1/3 sine cubed of x plus c. One thing you probably notice when you evaluate indefinite integrals is that you often get answers that you would never have really predicted, right? Like, who would have thought that the derivative of this guy here at the bottom is just cosine cubed? It's hard to predict that type of thing. So often your answers can be, even if you have a very somewhat simplified indefinite integral where it looks like something very simple, its antiderivative might be something really complex, which is kind of the interesting thing about indefinite integrals. And now number 11 is really just a symbolic exercise, because you'll notice I've got an f in there. If you're taking the AP exam, if you're watching this and you take the AP exam, this is like the classic type of thing that would show up on a multiple choice. Oh, by the way, on the left one, I should notice that this will work. This idea of using this trig substitution, the sine squared plus cosine squared, that will work anytime you have sine to the n of x, cosine to the n of x, and n is odd. This technique of peeling off a sine squared or a cosine squared and using an identity, that will always work for those types. So, sine to the 5th, sine to the 7th, cosine of the 7th, etc. Those are all, you can use this technique above that I just showed you, and it should work out. But again, number 11 would be a kind of a classic multiple choice one, and the idea is to understand substitution method using just symbolically. So I see this 6x to the 5th, so I'm going to let my u be that, because I noticed that I got a 7x to the 4th over there on the left, and that they differ by a power. So if you let your u be 6x to the 5th, and your du be 30x to the 4th dx, Well, then my integral becomes f prime of u, and I've got that 7, so that's kind of weird. What I might do instead is just replace the x to the 4th dx with du over 30. So x to the 4th dx is du over 30, so du over 30, and that 7 is just staying. It's just a constant anyway. So this ends up being, I'll take that 7 out, 7/30ths, the antiderivative of f prime of u du. But the antiderivative of f prime of u du is just f of u. Okay, and resubstituting, we get 7/30, or 7 over 30, f of 6x to the 5th plus c. Notice when you check that, you'll get exactly what we see up there inside the integral, because you get 7 over 30, so you should note that I'm taking the derivative. So the derivative of 7 over 30 f of 6x to the 5th plus c is just going to be 7 over 30 f prime of 6x to the 5th, right? Then, because of the chain rule, I got to times by the derivative of the inside, which is 30x to the 4th, and the derivative of c is 0. You'll notice that these cancel, and you got exactly what we see up there inside the integral. Alright, so you can always check your answers when you're done. And that brings us to the end of a long stream of examples using u substitution. And so at this point you just need to get practice. There really is no substitute, no pun intended. There's no substitute for practice.